doing things fast is, I think Bill or Steve Piper typed in a random 1500 by 1500 matrix and inverted it. And that took 2-point-something minutes. And I said, that's pretty slow, isn't it? Until I sat down and one day and calculated. This is over 1 million elements that they've been working with doing operations. And the interesting thing is it's exactly the same as doing the inverse on that thing except for timing. And Felix has set up a nice little program here, which you can see, and I hit the button here, end, and there's some pauses. We're tied to a computer at Kingston. I got some messages from the people. How do I get the screen cleared? Okay, it just started doing scalar execution of a matrix inversion. I'm sorry, we didn't read it. It's a 270 by 270 random matrix. It's using an algorithm which we developed many, many years ago, and it took 25 CPU seconds, and you saw the real time. I will now hit the button again, and hopefully no more messages. It's waiting a little bit. It started the vector execution, and it's done. So it took 0.76 seconds. So you see a rather dramatic increase in capabilities there. You've gone from 25 seconds to less than a second. From the user perspective, it's exactly the same program, right? It's exactly the same words. And that becomes rather exciting because suddenly a naive user who doesn't know how to program is using a supercomputer to solve problems, which is rather an exciting concept. So we have somehow ended up being in an environment where Speakeasy is very valuable for supercomputers. Now, one of the reasons it's going so fast is that IBM has produced a library for their vector. It's a library called ESSL, which is very, very carefully tuned for the vector computer. It's Fortran callable, but it's a routine that's written in assembler for that machine. It makes use of every capability this team of people can think of to make it run fast. And you can see it has rather dramatic effects. From the user viewpoint, there's nothing different except he's using the resources of all these people who developed the library. That's essentially been our philosophy in numerics all along. I think that concludes it unless people have some questions. I'd be very happy to answer any questions. Yes? Else? Well, we're working on if-then else. It won't come out in the form of normal if-then else's, okay? It'll be something which is a little more friendly to a user, I would say. If you know if-then else, then you're a programmer, is my perspective. And I grew up with Fortran that didn't have if-then else, is the major reason it doesn't have it. The problem with if-then else is a philosophical one. If you have lots of nested if-then else's, it becomes very confusing. You may not agree, but we have verified it ourselves experimentally. Our feeling about Speakeasy programs is they're not really programs in the sense that you write decisions like that. These are supposed to be 10-liners typically that do the operation you want to do. If you have to invest a lot of effort in programming, which is what you're saying, then you probably should do it in Fortran and write a linkule. There is one interesting statistic. Our users are aircraft companies, semiconductor manufacturers. You sort of Procter & Gamble is a user. We have lots of Miller's Brewery's a user. It's a very strange user community, but there is one statistic that is common to all of them. In Speakeasy, you can monitor sessions if you like, and the common thing is that all sessions seem to average out at 20 minutes. And this is essentially the attention span of somebody trying to solve a problem. If he hasn't solved it in 20 minutes, probably gets frustrated and leaves, or solve the problem. And often that's what's happened with Speakeasy, you solve the problem. It's an environment which you have to understand. You have available all these ideas, and if you suddenly have a new idea yourself, you want to go off in a different direction. The tools are right there. You don't have to program. You just use them. And it takes a while for you to learn that, in fact, you don't have to sort of understand all the details. You just try it, and it gives you new ideas and go off that way. And I didn't show error messages, but if you try doing something odd, you'll get a very friendly error message saying, I don't understand what you're saying, and it tries to identify what the problem is. Good. You had a question?
The math team commits to multiple integration of user-defined functions.
This is doing numeric integration.